Awesome. Thanks, Wesley. So this meeting is just going to be, it's kind of just an introduction to ReEDS, where to find it, how to actually get it up and running, and then some common issues and troubleshooting. So let me share my, sorry, I hit the mute button and said, let me share my screen. And then we can just walk through this. All right, can you guys see my screen all right?
Yep.
Okay, awesome. Okay, so just a quick overview. Where can you actually find ReEDS? So ReEDS can be found on the nrel.gov page. The link's at the bottom of the website. But from there, there's a link to the GitHub. And then that's where you can actually clone and download the repo for use. So some initial setup stuff. So the required software, it's just GAMS and Python, and GAMS does require a license, but I believe you should be able to run it with the demo license. I think they give you like a couple weeks to use the demo license, but then there's more detailed information on the setup in the README that's on the GitHub, and so that's the link to this. And I'm not going to go super in depth into that right now, but if you have any questions, feel free to drop them in the chat or speak up about it. So for getting started, there's a couple different files that I think are important to look at, and I'll look at these, like we can look at some examples together. I just wanted to kind of give an overview of what those files are. So the first one is the cases.csv file, or the cases underscore asterisk, and I just put this here. It can be anything. I think there's a couple ones that are in the repository normally. So there's like cases underscore tests and then cases underscore standard scenarios. But what these files are, it's just the scenarios or the cases that will be run when the model is actually called and when the model's run. The second thing here is the runbatch.py file. This is a huge file. We're not really going to look at it, but I'll talk a little bit more about it. The gist is that this file processes the arguments that are defined in the cases file. And then what that does is it'll create this call underscore case.sh file or batch file, and that file issues the commands to run the case. So the runbatch.py file, so what this does is for every single case that is specified in the cases underscore test file, it's just a specific case. So what this would do, it would copy over the necessary files to run the case into a subfolder. So it'll create a runs/case folder. It'll note the case specific inputs in that runs folder in an inputs case file. It will create a call underscore case file, and then it'll issue a command to call that created file. So I know it's a lot of information. I'll pause really quick if anyone has questions. Okay. So the last slide I have here is just about this call underscore case file. And we'll look at this together. But what happens in this file is some input processing. So that's what happens first. So it'll run a bunch of Python scripts to process the input data for the actual model run. It'll call a file called createModel.gams. And what this does is it basically has a couple lines, but it'll process the CSV file, like the data in the CSVs, and it'll translate that data to GAMS. And then this is where the objective function, variables, and constraints are actually defined. And then it'll prepare the case to be solved. The third thing that happens in this call file is it'll start solving a set of years sequentially. So it starts at 2010 and then it'll just go to the end year. And I think the default is 2050. So it'll go 2010 to 2050, and then it'll do some output processing. Okay, so then let me just look at here. The first thing I wanted to look at was the cases file. So if I were to download ReEDS from the GitHub and then open that folder, this is what I would see. So there's a bunch of files in here. There's the run batch file, which is the main one. But then there's also a bunch of these cases files. And so there's all these cases.csv files. I'm just going to open this first one. So the cases.csv, this is going to have all of the switches, all of the scenarios and cases that you can run, and then it'll also have the default values for those. So this first column here, this is all the switches, all the different cases. I think there's like over 200 lines. So there's a lot there. We're not going to look at them all. And then there's, for every switch, there's also a description for what that actually is. And then some of them have choices in this third column. You can see not all of them have choices listed out. And then this column D right here is the default value. So if I were to just run the model and not change anything about it, this is what would be run if I use this cases file. So it would run until 2050, and then these are all the data references that it would use. If I wanted to actually change the model, so if I wanted to specify, I wanted to change some of these switches so that it would run my specific case, how I would do that is, you can see here, I have this reference sequence column. So this is the only one, it doesn't have any value here. So this means it's going to be run. If there's a 1 in this column, it means that the model is going to skip over that case. So we're not going to worry about those. But for this example, I wanted to change, say I wanted to run it, instead of running it to 2050, I only wanted to run it to 2040. So what I would do, all I have to do is go 2040 and then save that file. And now when I go to run the model and I use this cases file, it'll use this information in this column. So it'll look and it'll say, oh, there's a value here for the end year. Let's only run the model to 2040. If there's nothing specified, what happens is it'll just look, it'll say, hey, there's nothing here. Let's just use the default value. So that's, you don't have to fill out every column. It'll just use the default. And then the other thing, there is a smaller example. If you don't want to run the whole, like all these cases, you don't want to worry about all those switches, you can look at this cases_test file. And so this is a smaller run. It's just Pacific. So you can see here, the 2 cases I have created for the test, it's just Pacific and then Pacific high natural gas. And so it's just doing it until 2030. And then what I did differently, what I did was I added this certain case, the natural gas scenario. You can see I left the first one blank here. That's just going to be my reference case. And since it's blank, it'll just reference the default. And then I put in this AEO reference for the second case. Okay. So then moving on, so I did run these cases yesterday just so that we had an example here. But what this is, I'm just using Visual Studio Code to look at the code base. So this is the ReEDS repository. You can see here, these are the cases files that we looked at in the Finder. But when I actually run the model, it creates the subfolder. So I can go here, runs. These are the 2 cases I ran yesterday. So 12_11 2023 Pacific and then Pacific high natural gas. I can click into these. And when I run the model, as I said earlier, it creates this the call case name .sh file. And mine's an sh file because because I'm on a Mac, but if you're on Windows, it'll be a batch file, so it'll be .bat. So I can open this, and then I just want to walk through this. I know I said it in the PowerPoint what this kind of looks like already, but basically what happens here, it has some initial setup at the beginning, but then this first section here, this is where it actually does all of the input processing. And so it'll run a bunch of Python files. So that's basically what's happening is it's using Python and it's doing all these input processing. So it's like copying files. That's what this is doing. It does some financial input calculations, a bunch of stuff like that. Scrolling down right here. So line 66 to 68, this is where it's actually calling create model.gams. And so that's what this like gams create model.gams is doing. And what happens here is it calls create model.gams with a bunch of inputs. I think this line is like super long. And then what it's doing is it's doing all that input processing, setting up the model, and then it's creating this file right here called, it's just my case name as a file. And that file is going to be used when it actually goes to solve the first year of the model. All right, so then after it does the call to create model.gams, it'll start solving the years. So as I said, it starts at 2010. And what happens for each solve, right? So what it does this, it calls this TC phase out Python script, and then it'll actually call gams solve 1 year. So what happens there is it takes the previously created file. So it'll take this file that was initially created in the GAMS create model step, and it will use that and it'll solve that year and then create a new file named 12/11/2023 Pacific 2010. Okay, and that's going to be different. It's going to depend on what you decide to put for your actual like run name. And then it's just going to increase the year and it's going to go to the next year. Okay, so because it starts at 2010, I think 2010, it goes 5 years until it gets to 2020. So it'll go 2010, it'll go to 2015. And now 2015, what happens here is it'll do the tax credit stuff, but then it'll solve 1 year using the previous year. So this time you can see it's taking the 2010 file. So it's taking the file that we created that was created in this step. It's solving the year, and then it's creating a new file called with the 2015. Okay, and so that basically happens over and over again. The only difference is that once you get to 2020, we have another step that gets added in, and it just calls the augur module. And so then every single year after 2020, it goes 2020, and then it'll just iterate every 3 years solving the model. That's the default. So it'll go 2020, and then it'll go to 2023, and it'll just continue until the end. And so if I scroll down, my cases underscore tests was only going to 2023, or not 2023. It was only going to 2030. And so that's why you see the last year that gets solved here is 2029. Okay, after all of the solves happen, it just does some output processing. And so what happens here, it just does some reporting and then some plotting and stuff like that. All right, and then I wanted to go over, that's basically the gist of what happens in this call file. How to actually, if I wanted to actually run the ReEDS model, all I'd have to do is do Python, and then I want to call this runbatch.py file, because as I said, we're not going to look at the runbatch.py file, but that's the main file. So I'd want to do this, hit enter to actually run that from the terminal. And then the first thing it asks you is the batch prefix. And so this is what you're going to see. So I put in 12/11/2023 Pacific for my batch case. You can really put anything. If you leave it empty, it'll just default. For this example, I'm just going to go 12/12, and then I'll put my initials. After you do the batch prefix, it asks you to do the cases suffix. And so this is important because this is how you tell the model which file to use, which switches to basically use. So I showed the generic, or like the general cases.csv file. If I leave this blank, it will just call that cases.csv file. But since I made changes to the cases_test file, and I want it to run my specific tests that I set up, I'm going to want to put tests in here. And then what's going to happen is the model's going to see this, and it's going to call the cases_test.csv file. That's what's going to be referenced in the model. So then, yeah, you can see here, it looked at that. It sees 2 cases that want to be run, Pacific and then the Pacific high natural gas. And so the last thing it's going to ask you, and it won't ask you this if you only have 1 case being run. I don't think you'll see this every time, But basically it's asking you how many runs do you want to do at the same time. And so you have the option here to specify if you want it to run just the Pacific case, and then after the Pacific case is done, you want to run the Pacific high natural gas case, you would want to put just one. It'll only run one case at a time. It'll wait until the first one's done, run the second one. Because it's two small cases, I'm just going to hit 2, and it'll run both of them simultaneously. Okay, so I hit enter to actually continue it, and then basically it's just going to print a bunch of stuff and then run the model. If I wanted to look at it, I can go back to, this is just the same view. It's the same thing, just a different view. I can go into my runs folder from here, and you can see it already created those 2 subfolders. But if I were to actually click into it, it wouldn't have all the information in the outputs quite yet. Okay, so then I'm just gonna let that run in the background. If I wanted to actually look at some outputs, there's a couple different ways to do that. So I'm gonna go back to my example from yesterday just because I know it's there and I know it's completed. I go into the runs folder, I go into the outputs. This is a bunch of the output data you can look at. If you wanted to just see like an overview of what the outputs were, I can scroll all the way down. There's 2 things that I wanted to call out. So there's this ReEDS report folder, and then there's a ReEDS report reduce folder. I think that's the second one's pretty straightforward. It's just a copy of the first one. It's just a little bit smaller, I believe. But how I can actually look at this, and so there's a couple different things. I can click into this report.html file, and what this is going to do is it's going to bring up a new window on my browser. And this is actually the output data. It just builds it into nice plots using Bokeh Pivot. And if you're interested in that, there's a whole training on the YouTube playlist, and I can send that link out in the chat after this on Bokeh Pivot, how it's working and stuff like that. But this is just a nice view of an overview of like the results of the run. And the cool thing about this is that it's actually interactive. And so if I wanted to move around, I could do that. If I wanted to look at like a subset of this data, I could do this and look around, and you can always reset it. I'm not going to go super in depth there, but that's one way to view it. The other option, so you can see here, before I move on, one quick thing. So that's the report.html file. There's also this report, this Excel file that has all the data behind these plots if you're interested in looking at that. And then this ReEDS report reduce also has the same thing if you wanted to click and look into that. The other way that you can look at the outputs is there is this compare cases file, okay? And where that's located, it's just in this folder, post-processing, and then compare cases, okay? We don't really need to go through that. Basically, what that's going to do is it's going to take 2 different runs and then put together a handy PowerPoint that lets you visualize the results and compare them to each other. So how to actually run that, you're going to do the same thing. So Python, and then this is that post-processing. I just have to specify where it is, and then compare cases.py to actually call it. But then it takes 2 inputs. So the first input here is the path to my first run, right? So this 12/11/2023 Pacific. And then the second input is the path to my 12/11/2023 Pacific high natural gas case. Okay, and then once I specify those, I can just run it, and it's gonna do a bunch of stuff. But basically what it's gonna create is, I can show you here. So I already opened this yesterday. But it's going to create a PowerPoint like this that basically takes the 2 different outputs, and then it just will put them into a nice visual for you to actually compare the data. All right. I don't have anything else. Does anyone have questions? Otherwise, I'll pass it to Wesley. to continue and talk a little bit more about some common issues in troubleshooting.
Yeah, so there's a few questions in the chat we'll get to. Are there any questions about what Kennedy's covered before we get to some of those and talk about looking at runs and make sure they finish correctly? Okay, so just a couple questions that came up in the chat. Let's clarify. One, questions about licensing. So because ReEDS is written in GAMS, you do have to have a GAMS license to be able to run the model. There are, if you're associated with the university, there's I don't know all the licensing details. You need to talk to GAMS, but I know you can get like trial licenses and other things to try things out. When you run a large instance of ReEDS, open source solvers won't solve the model, or at least we haven't been able to get them to solve the model. So we use a commercial solver, Cplex. We found Cplex to be faster than Gurobi for the ReEDS, for solving ReEDS. So we use Cplex to solve our large instances. If you're solving a smaller portion, like we could solve ERCOT with an open source model, it takes quite a bit longer, but it still works and doesn't need the commercial solver. So then other questions about setting up cases. I'll walk through some of that in terms of what that could look like. And then if somebody asked about bokeh, if you need any more questions about bokeh, you could happy to ask more or show more besides what Kennedy talked about here. So let me share my screen and we'll go through a couple things here. So so a few things. So people ask about setting up like different temporal resolutions. You can get some examples of what other cases look like in these cases files that already exist here. So again, cases.csv has everything in it. So every single case you could change is in this file. There's a lot in there, and like some of them have been used for years. So I'm certain that some of them don't even work anymore, but they're all in there, and you could get, if you want to just go through and get a sense, but it could be overwhelming to go through this huge list of things and be like, oh, what do I actually want to change? So instead of starting with this file, I don't recommend that. I recommend starting with a good starting place is this cases standard scenarios file. This is the one that we use for our annual standard scenarios report. So this could be a little bit more digestible. So you'll notice there aren't nearly as many in this. We have 42 rows in this file as opposed to the hundreds of rows. So anything not specified in here is going to use the default value from the cases file. So for example, this Windows suffix switch is not included in here. So that means Windows suffix is going to use default because it's not specified. So the cases standard scenarios is only going to overwrite whatever's in there based on what's specified in this file. When we ran the standard scenarios this year, we have 54 cases. So there's 54 scenarios in the standard scenarios, and you can get a sense of what they are. So here's our mid case with no nascent technologies. So we've turned off technologies that are commercially available today. So this, you can get a sense for, okay, what did they do to run with no nascent technologies? Well, we have here no floating offshore wind. We've turned off BECCS, so bioenergy with carbon capture. We've turned off carbon capture with storage. We've set geothermal from a switch of 2 to a switch of 1. When you look at this, 0 is turned off, 1 is a default, and 2 is extended representation. So extended is like enhanced geothermal systems that don't yet exist today. So you can see what we did to run the standard scenarios cases, the things that we changed. You saw Kennedy using a high natural gas price scenario. Here's the switch that was used to do this, where it's using AEO 2023, low oil and gas scenario for that. So these are, I think, relatively intuitive into like low renewable energy costs, high renewable energy costs. You could look at the report to get a sense for what's in there, but this will give you a good starting point for, here's a whole bunch of scenarios that we've run. And you could look out here, we've got all these 95% by 2050 decarbonization scenarios and 100% by 2050 decarbonization scenarios. So you can look at how we set those up and then know what switches you might want to change in order to get the case that you want. So I definitely recommend this as a nice reference for seeing what those scenarios look like. Other cases files that could be useful for you here are, this cases test is nice because it's smaller. We use this for testing. It could show you how to set up these small cases. We designed this cases small to be able to run with the trial license from games because there's a limited number of variables and constraints allowed under that trial license. May have changed, maybe it's bigger now, but so this turns off a whole bunch of stuff. So you can see mostly what it's doing is it's turning things off so that way we get a really tiny model so that the model will solve with the trial license without exceeding the number of constraints. So just for reference, I think a trial license lets you have 5,000 variables and constraints, and our full US model has something like 2 million variables and constraints. So it's quite a bit difference in size. And then you can see other things in here like this cases hourly was built when we switched over to using the hourly ReEDS, that, where we have many representative days. So there's different ways you could see how we set that up with representative weeks versus using a full year of data, and how, so you could look at here to get a sense for what was getting changed to look at different sets of days. So ReEDS has a lot of different options, capabilities. If there's a piece in there you really want to dig into, we could certainly do that. So one of the things I want to show, well, I guess let me pause there. Any questions before I move on? Okay, let me go. So I want to run through some of the common issues you'll see as you start running ReEDS. So if they happen to you, then you know what to do with them. So like Kenny was showing, when you do a run, it will show up in here. Here's that Pacific test case. She was doing this one. When a run is done, you should have outputs. This is how you know it finished. There's all these CSV files are populated. You have these ReEDS HTML reports that you can look at. You might do a run, and this was actually good. I ran that cases small, the one that's supposed to run with the trial license. I ran this on the 7th, so last week, and I haven't come back to fix it. This was great. Give me an example here. So I come in here and say, did this finish? And you look in the outputs and there's nothing in there. It's just like, oh, it didn't finish. Where's all my CSV files? Where's my HTML outputs? They're not here. So this run fails. This won't work right now. So we're going to fix it, and you'll be able to run it as soon as we're done with this because we're fixing it here. So what happens if a run doesn't work? You say, what's going on? So the first place you'll want to look whenever a run doesn't work is there's this gams log.txt. So this includes the outputs of your run. And so you can see when Kennedy was running and it was printing everything, this is what it was printing. If we just go to the very end of this, it said there were compilation errors. So it says, hey, you got a problem in the code. So this is a GAMS error because GAMS is a compile language code. So we've got an error in GAMS. The GAMS files are LST files. So if you never use GAMS, this will be new, and you may not want to get involved. If you have used GAMS, you'll be familiar with this, that LST files are the GAMS output files. We could open this up. The key to finding errors in a GAMS LST file is you search for 4 asterisks, and it says, we've got a problem here. This parameter geodiscovery factor, so our geothermal discovery factor, it's empty, and empty data states are not allowed in GAMS. So we need to put this on, off, empty around it. So this is a pretty simple fix where we could just go in to the inputs, look for this, and this is the kind of thing, we'll just fix this. You don't have to. So we just need to put, you can see how some of these other ones have an on empty, off empty around them. This one needs an on empty, off empty around it too, and then it should work. So we'll push this fix up to the repo, and then should be in good shape. So let me show a couple other pieces here that'll be useful to look at. So a couple other common errors you'll see. There'll be, let me show you this actually. So in our in our discussions page on the repository, so the discussion page where people have posted, hey, we've had this error, we've seen this thing, or we have this question. If you have questions come up later, discussion page is a great place to post them. I'll open up the, so it's got a whole bunch of, you know, Q&A announcements, whatever pieces up here. So if you have questions about using the model, feel free to go here and just make a new discussion item and we'll respond to it. But you'll see people have had errors where they get this long cryptic error and like, what's going on? And it's saying, it can't read a file. And one of the things that happens is in the repository, we have in the inputs variability multi-year folder, we have all of these files. These are hourly, these are all the hourly profiles for the wind, solar, and load data. Used to be CSV, GZ, they've been changed to H5, so they'll look like this currently, these H5 files. If you didn't check out the repository using Git large file storage, the Git LFS, it won't check these files out. These are too big for a standard repository. It won't store them, so we have to use Git LFS to store them. So if you don't have Git LFS set up, these will show up. These will look like 1 kilobyte files in your repository. So this is the thing that commonly shows up is somebody will run it and they'll say, hey, I'm looking for this H5 file and it's not there. And that's because it's just a pointer to the big file, but Git LFS isn't installed to be able to download the big file. So this is a common thing that happens to people is that if it's the repo is not set up with Git LFS, these really big files will actually be just pointers and won't have any real data in them, and then ReEDS will fail because it tries to read data from them and it can't. Another common thing that happens is with a package. So I'm going to go in here and so this is calc financial inputs. This is one of the input processing pieces. You can see it's here in our input processing folder. It's what does financial calculations. If you don't have one of the Python packages installed, this one's one of the hardest ones to see because it's kind of cryptic. But let's say I'm just going to add a new package, Pygame, put an Easter egg or something here, or whatever. But if you have a package that isn't installed as part of your library or part of your environment, then when I come over here, we're going to try and run ReEDS. So we do that Python run batch.py. This should create an error. So I'm going to call this case error, and I'm going to run a small one because it's the fastest. So it's going to run, I'm saying what cases, suffix, we're going to run cases small. So it's going to kick that off. It launches it in another window, and you can see it just failed, right? Like it just disappeared. It says it's finished, which it is finished, it's done. But ReEDS takes longer than that to run. So we know it failed because it stopped running so fast. So if we go to this runs folder, here's that case we just ran. We look at it, it's like, oh, look, all these files are here, must be right. Look at the outputs. Oh, it's empty, it didn't work. So where do we go? We go to the gams log file. So that gamslog.txt. And this one is where it's cryptic. It's just like, oh, it started copy files and then it finished copy files. And there's nothing. It's like, what happened? It just stopped running. So if we go back to this call file that Kennedy was showing us, we'll open it in VS Code. So you can see the first thing it does is it starts copy file. It does copy files, so ran copy files. And then the next thing it does is this calc financial inputs, and it didn't make it. So in this case, if I didn't know what was going on, I'd say like, well, it did this one first, and then it's doing this second. So let's copy this command. And let's come back to our command window. It's already changed the file. It's in the runs folder, so we need to go to that runs folder. So once we're in there, we could just put in this command that it ran. And here's the problem. It was trying to import this Pygame. But I haven't installed it. That doesn't exist. So like if you were trying to run ReEDS and something is like GDX PDS is one of the packages. If you didn't set up your environment to include that, it'll fail on the import. It won't show up in the gams log. But you could find it if you're working through things. So that's a fairly common thing, is that somebody will not have a package set up and that you'll get a failure earlier on. So if we took this out, then we'll go ahead and so now if I come back, pull that out and rerun this one line that's running the calc financial inputs. Oh, I changed, okay, here's my classic piece. I changed it here in the input processing, but when we run a case, it copies all the files over. So here is the copy of input of CAD financial inputs that was copied over. So I have to actually remove it from the one in the runs folder. And then if I do that, then it should run fine. So then it completed. So we now have a successful CAD financial inputs run. So those are a couple things you'll see that you might run into as you're trying to run ReEDS. Then last thing I want to show is you might have, let's say you want to do a new run with a different set of costs. So let's look at our cases file. Let's look at a different cases. Let's look at cases standard scenarios. So you can see, low renewable energy costs. There's for the UPV cost and performance, they're coming from this UPV ATV 2023 advanced. The default is UPV ATV 2023 moderate. Let's say we want to run a case with a different set of PV costs. So we're going to change our PV costs. So here's what the default is. So let's go find this file. So you'd say, okay, well, the default is this thing. What is that thing? We could go into the inputs and we could just search for it and say, find me that thing. And here's where the input is. So it's an input plant characteristics. So I'm going to go ahead and go there rather than just opening from that spot. So inside input plant characteristics, we have the UPV costs. UPV moderate is the baseline. So let's say we wanted to just run a case where we're going to say, I want to run the moderate case, but I want the cost to be cut in half. So let me open this file. So here's the capital costs, FOM, BO&M, and then the capacity factor improvement. So it's saying the capacity factor is going to improve over time to because of bifacial modules and other pieces. Okay, so let's say I want to run everything exactly the same, except I want the capital cost to be run in half. So I'm going to make a new file in here. It's instead of ATV 2023 moderate, I'm going to call it ATV 2023 half. So I've made a new case, and I'm going to let's see, it's 2023. So let's go 2023, delete all the data between, and I want this one to be half. So I'm going to take that divided by 2. We're going to just paste in the new numbers in there. So here's half of what the old value was. And then we're just going to interpolate the values in here. And then, okay, so now we just have from 2023 to 2050, we now just have this linear trend that gets it to half. Okay, so I have a new cost performance input. I'm ready to run with this guy. You say, okay, well, I'm just going to run. Let's pull up. Let's go to the cases test to run it. So we'll open up our cases test file. We're just going to test it with the Pacific case. And so we need one new switch. And we say, okay, well, what was the name of that switch? It was, where was it? This guy, the UPV scenario. It's called UPV send. Here's the name of the switch. So I take this guy, I'll add it to my cases test, and I'm going to put in my new name for my file, which was this guy. It's this UPV 2023 half. So I put that in here, and now I'm going to run with that instead of the default. So we just say, hey, we're good to go, and we're going to run, right? So let me clear this out. I'm going to go back to our folder, and we'll kick off ReEDS for this one. This is our UPV half scenario, so we'll call it that. And then we're running, this is the test cases test. So we're going to run with the test cases file. So it's going to run it, kicks off the new, it opens the new window, and it starts going through running everything. And while it's doing that, we're going to pull up our window here to to, so it's running our UPV half, it's cranking away. But then it ended pretty fast. It should take longer than that. There's no outputs in here, so it failed. So it's like, what? We just added this file. What's going on? Why didn't it work? We open up the GAMS log, and you could see it's throwing this error in Python in this plant cost prep file. So that's indicative. Plant cost prep sounds like power plant cost, and we just changed power plant costs. And where's the error? It's in UPV. Well, we just changed UPV. It probably has something to do with what we just did, right? So, and it's failing in this line, deflate equals $year, where it's in this $year matching here. So this is the issue going on here is we just put in a new cost into the model, but because ReEDS has costs from lots of different things, everything has to be put in a consistent $year. One of the things we didn't specify was, well, what $year are the inputs we just used? Are these current dollars? Or is this 2018 dollars? Like what's the $year for the inputs we just created? And that's what it's failing on. It's trying to look up a $year for what the scenario we've done, and it can't find it. And this is the kind of thing of like, oh, if you've never run ReEDS before, you probably wouldn't think about the $year and how it's set up. So we have in this folder where everything is, there's this $year.csv file that has the $year for every scenario that's in this folder. So we just created a new UPV case, but we didn't tell it what $year it was in. So we said, well, it was going to be half of what it was before. It should use the same $year as the other one. So we have this, we made a half. Now it knows what $year to use for the new inputs we created. So now if we run this again, it should get farther because we just fixed it. So we'll go ahead and kick that off and let it start going. But that's the kind of thing of like when you run something, you don't know what to do. Open up the folder. You know, did it fail? Well, you could tell it failed because there's no outputs. You could also tell it failed because it finished really fast without getting to any kind of solve statements. We're able to go to the GAMS log and hopefully understand what's wrong. If you look at the GAMS log and have no idea what's going on, you can always post something in the discussion page, and we'll probably be able to help. No guarantees ever that we'll be able to solve things, but you're welcome to post something there, and we can weigh in on what we think might be going on, and then maybe fix it and start rerunning things. So, so you can see this one has made it farther. Like, oh, this stuff's new; it wasn't there before. So it's gotten farther than it was before. So we're in a good place in terms of it's making more progress. So you'll also see things like you can see these error messages in here. Some things get printed as errors. I'm not sure why this happens, that they'll get printed as errors, even though it's not a real error. So I can't help you with that. I'm sorry, but you can see it's starting to move through. It's doing, these are actual GAMS pieces where it's setting up a matrix, solving it. Those sets of numbers are where it's actually solving the matrix using the interior point method. So it's doing iterations and making the solve. So we've now, like this is moving through. It looks like everything's working fine. So we now have the model set up sufficiently that it's going to move forward and get us a solution. So that's exciting. We have a functional model now. Yeah, so let's see if there's any other errors we want to cover. I don't think so. So that's the basics of what the kind of stuff you'd expect to run into as you're running the model for the first time. There's certainly a lot more advanced things, like you're going to start developing the model. You want to add a new constraint or add new code. That's kind of a different layer, but we're not going to go into that today. So I'm going to pause there, and if there's any questions, happy to take them. Okay. Are there any other like cases or setups or anything you guys have questions about? And like, how do I set up a case that does this kind of thing, or how do I do this? Like, I'm happy to walk through any specifics as best as I can if you have questions on a specific thing you're interested in. Okay, then the last thing I'll highlight before we end, this one's almost done, but we won't wait for it to finish, and we go back to a case that did finish. As you're looking at, the outputs that write out, you will see things like down here, this retail rate calculations has a bunch of errors in it. This retail rate calculation, it only works when you do a national run. It doesn't work for a ERCOT run because there's state level data and ERCOT's a sub-state, but since it pulls FERC data for the states, it's always gonna, like this one's always gonna error for some regions, or like it's just not set up to run subsets of the country because there's complications with running subsets of the country. So you'll see this kind of thing that's pretty common, that like, yeah, you're not gonna get retail rate outputs for running a subset of the country. And that's just the way the model's set up. And we haven't gone in and made it like fail nicely. I'm just like, we should just say skip this if it's a smaller subset, but we haven't done that. So you will see some things of like, oh, did my model fail? No, everything, as long as the outputs are there, as long as you get these HTML reports, like this is a successful run and completed successfully. You won't have you don't have any retail rate outputs for this run, but that's okay. It's got the bulk of the kind of stuff you need. Okay, so somebody's asking about running the ERCOT case, but importing and exporting from other states. That is not a feature currently in ReEDS. So ReEDS doesn't have any capability to have exogenously specified imports or exports. ReEDS only knows about the regions that you're modeling. So in the specific test case, ReEDS only knows about the specific test case, and that's all. So like California imports a lot from Nevada. California is in the Pacific test case, but Nevada's not in the Pacific test case. So there is no import export from Nevada. There's no way to specify that currently. I mean, that wouldn't be super challenging to add it. Like that's the kind of thing you could add, but that would involve going into GAMS and changing the GAMS code. So if you've never done that kind of thing before, that would be challenging. But otherwise, everything is just within whatever regions you model. So if you wanted to capture those, if you were looking at ERCOT, you want to capture imports and exports, you'd need to run more than just ERCOT to have those other regions and transmission connections represented. Okay, any other questions? And our UPV HAP run finished, and created our report. So this is where, like, if we went and did a comparison, like what Kennedy was showing us, we should be able to go in and see that there's more PV than prior. I haven't looked. I mean, it's possible we have something else wrong, but like I was kind of expecting more PV in this, so maybe it's not. I don't know. Maybe we did something else wrong. It's possible we broke something. This would be the kind of thing now of like, hey, did it run right? Am I getting more PV than I was before? If the other one didn't have this much PV, then there's probably something else going on. It's like, are we seeing more PV when we cut the price in half? So this is the kind of thing I'd look at. And move forward, and again, if you can't figure something out, drop it on the discussion page. So that's all the material we have to show. So yeah, one more question about defining transmission lines. Let me just show you where transmission is real quick, and then so I'll do a couple pieces. So one, in inputs, you could just start looking and saying, where is stuff? There's a transmission folder. So here's where transmission inputs are located. There's two primary files. There's init, this is your initial capacity, and then there's future. So this is future capacities. This is if you want to require certain lines to show up. You could use this future file. The initial is obviously what you start with, what your initial capacity is. So if you wanted to prescribe transmission lines, you could create a transmission capacity future file that has the transmission that you want to be prescribed, or you could use the ones we already have here. So these ones are from the SEAMS study that was published by NREL a while ago. And I'll just open one of these files up here. So this has from one region to another region. So if you haven't seen the ReEDS map, all the ReEDS regions start with a P. And then you could label them as certain, which means the model has to build them, or you could label them as possible, which means the model could choose whether or not to build them. So you give it the option to build it, but the model chooses what to build. You specify the transmission type. I don't remember what LCC stands for. The other one is VSC, and they're different DC overlays in this case. You could specify a year in this column here. They're putting 0, and like it doesn't. I don't actually know what the T meaning 0 is. I'd have to go and look at the code and see what that does, and then how many megawatts the connection is. So this is the kind of thing that you could set up in a lot of different ways. And then if we go, I'm going to go back to our cases file. If you want to just start looking at what transmission options are available, you could search for transmission. So you have financial assumptions, how operating reserves are traded across transmission lines. And then we have this long list of transmission switches. And so you could read through those. So this is like, what's the maximum maximum transmission capacity allowed across interfaces? So if you want to set limits there, or how much can you invest in the near term and long term? Do you want to have hurdle rates? Do you want to restrict where transmission could be built? This is where you'd set the different transmission scenarios of those switches you're looking at, so that LCC, LCC, SEAMS 3, all of these, that's the suffixes for these files are set by that switch. So there's a variety of switch types you could look at in here. And then the last piece I'll note with these is a lot of these switches, if they have G, that means it's a global switch. It's probably used somewhere directly in the model, as opposed to like that UPV send is just using the pre-processed choose which file to pick. But like this trans hurdle, if we come back to our model and we search inside for this trans hurdle, we can see where it shows up. And we can see it's showing up at, let me go here. Oh, this one is not showing up with the G. It's been converted, so that once they get into the model, the G gets dropped from them. But this is saying we have a cost hurdle from one region to another region. It's being set to whatever the switch value is, so the switch trans hurdle. So whatever value you put in to the trans hurdle, that value is going to come into this parameter cost hurdle. And then if you wanted to see like, oh, where's this getting used in the model, you could look at cost hurdle, and you could see, oh, here it is in the objective function. It's being applied against the flow across the line. So that's, if you want to just trace something, you could do that kind of thing to start figuring out where it is. Yeah. Okay, so I'm seeing more questions in chat, so I'm going to go ahead and stop there, and I think we'll close things out. So thanks for joining today, and hope it's useful. You're welcome to send us any more questions along the way. We're happy to respond. And definitely, if you have any feedback on like, hey, I'm using ReEDS, it'd be easier if this or whatever, we're open to ideas on how to make things better. So thanks everybody for joining. We appreciate it, and we'll go and close things out here. Thanks.